Hey everybody, welcome to my Physics 2212 Test 1 wrapper. The problem we're going to be doing today is question 2 from exam 1. So the first part of question 2 asks us to, actually, you know what, I'm going to show you the problem itself so you have some context. So the problem is 4 charges with identical magnitudes q are evenly spaced on the y-axis, so the distance between each charge is s. Collection of charges is centered on the origin of this coordinate system. The sign of the charges alternates as indicated in the figure. And there's your setup there. You'll get another picture of this in question 2. Anyways, uh, So part 1, we modeled this system of charges as two dipoles, a dark dipole composed of the two dark charges, and a light dipole composed of the two light charges. Calculate the dipole moment for the dark dipole and the light dipole. So this part was pretty easy. Copied and pasted my work, but essentially we're using the P formula for a dipole moment, and you're doing your QS P hat as like dipole moment equals QS P hat. But in this case, you have the positive and negative. Wait, no, never mind. Sorry, you have the distance being 2s, because each dipole, or at least every charge that's a part of a dipole, is 1s apart. And if you remember from the structure, we have like they're 2 apart from the other one participating in the dipole. So that's why I use 2s. And then q is the charge of each component of the dipole. So one's positive q, one's negative q, but you just use q because that's how calculating dipole moments works. So then for part 2, I lost a lot of points on this part. Because I assumed E net equals 0 at every point. But that's not correct because of the orientation of the dipoles. So as you can see, you have the positive and negative components of the dark dipole causing a net movement at D in the rightward direction. And the same thing happens for the light dipole. The reason why is because the positive charge of the dark dipole is above the negative charge. So it's going, essentially it's creating an arc from positive to negative charge. That's how the fields of dipoles work. So you have it moving infinitely along the positive y-axis and then looping around and then coming back down at, or around D, coming back into the negative, right? And so as a consequence, you get net movement in the D direction, or in the rightward direction at D. And B works the same way, but it's just on a reflected axis. And then A and C, they work in they go in the direction of the closer dipole. And I think it's kind of a bogus answer, to be honest with you, because we're assuming in this case that the D is much greater than S. So the idea that it would go towards the closer dipole sort of is defeated by the fact that we're assuming S to be negligible, right? So for A and C, I just disagree with the key on this one. I think that knowing the physics principles that I know, I think there shouldn't be a net movement in A and C. B and D makes sense why I missed that, because E net doesn't equal 0 because of the orientation of the dipoles. But A and C, you're assuming, if you assume that the direction is net movement away from the dipoles, in this case, like along the positive y at A and along the negative y at C, then your D is much greater than S is completely disregarded. So I think that's kind of a dishonest question, and I'm not a fan of it. But that's what the key says. So that's is what it is, right? And then for number 3, then because I assumed E net equals 0, I solved this completely wrong. But as far as just generally how to calculate the magnet of an electric field, at A, you're factoring in S here, right? And this is another thing that I just disagree with, because we're assuming D is much greater than S, so S is approximately 0 in relation to D. D minus S is 0, or D minus S is D, right? D minus S over 2 is approximately D. So the fact that in this formula we're looking at D minus S over 2 cubed should just be D cubed, right? Based on the assumption that we're asked to make in part 2 of the question. So once again, I just disagree with the solution. I think that if we're assuming S is approximately 0, when in relation to D, right? Like if it's D minus S, that's approximately 0. S in of itself is not approximately 0, but in relativity to D, S is approximately 0. So the fact that in this solution, then we're distinguishing D minus S over 2 as part of the solution is contrary to all we were taught in this course. And I think that that's a dishonest answer as well. And so similar to 2, I think I made mistakes, but I also think that P is wrong, especially with regards to A and D. And so yeah, I mean A and C, sorry, I'm very tired. But yeah, that's kind of my breakdown of this question. So if you want to solve it wrong, you can do it with the key set. But if you want to solve it right, then you can assume that D minus S is approximately D, or D plus S is approximately D, since that's what we learned in GPS, that's what we learned in class. And if you were to do that, then you would get a solution that's somewhat similar to what I got originally, which is let me show you all right quick. It'd be this. So it'd be D cubed at the bottom, and you don't factor in S because D minus S or D plus S is approximately D. Um, so this is what you would get if you solved it using the physics principles we learned in class. And finally, we go to number 4. And number 4, I got correct. E net equals 0 at any D is much greater than S, so the dipole does not exert an E field on a point very, very far from the origin in any direction. This is the only question where D is much greater than S was actually used by the key, so I appreciate that. And as you can see, my solution was pretty accurate to the key. But there were 3 possible solutions on the key that are relevant. The one that I relied on is that the sum of the dipole moment of the dipole moments is equal to 0. So that's number 3. But the other logic path you could take is magnitude decays faster than the dipole, and the direction is wrong on the x-axis. So you could also approach those ways and get it right. But as far as from my perspective, I find that the sum of potentials equals 0 is the easiest way to know this if you know how dipoles work. So yeah, that's my test 1 wrapper. I know it's a little unconventional because this isn't. I didn't fully concede to the key, right? But I think that it's important to address differences in physics thought, right? Because physics is not a rigid field, right? There's a lot of possibilities, there's a lot of ways of thinking, and I think that in this case, my way of thinking differed greatly from that of the professors. And I also think that the way we were taught is different from the way that we were keyed, and so I think that that's important to address sometimes. Sometimes you got to make a stand, and so hopefully I don't lose any social credit points for that take. But anyways, I hope you have a great night, and see you in the next one. Bye.